And then at the bottom of page 4 in section 6.5 notes, you're looking again, we're still in the Practice Plus section, and notice I didn't work out the previous one completely for you. I want you to get to the point where you're really pushing yourself and making your brain engage. What that'll do is get you more ready for the test. If you just copy what I do all the time, and that is your way of getting through the homework, in other words, you have to see somebody else do it first before you can do it on your own, you're not really forcing yourself to get test ready. So sometimes I will start you off on a problem or give you a hint, and then you need to take it the rest away. You need to engage your brain and make your brain cells make the connection. If you're struggling with that, give yourself some time, take a deep breath, come back to it. If you really can't seem to make that happen on your own, come to class and let's talk about some things we can do to help you with that. I've got some ideas. So here's another example where I'm going to give you a little bit of a start and then see if you can come up with this one on your own. As we look at page 383, number 82, 9x cubed plus 6x squared, the whole thing over 3x, minus, look at these huge parentheses here. We've got a really big fraction minus another really big fraction. 12x squared minus 4xy squared, the whole thing over 2xy squared. So again, take a moment. Tell someone how you would start. When you look at this problem, one big fraction minus another big fraction, both of the big fractions in parentheses to kind of give you a visual cue for what's happening, how they're setting it up. What's your instinct of how you would start? I'll give you a moment. So if you had a thought or an instinct that you would maybe deal with what's happening inside the parentheses first using order of operations, to me that is a great gut instinct, a great way to start. So inside the parentheses, and what will we do inside those parentheses? Well, we're in a section that focused on how you divide, how you split these fractions into how you split these big fractions into individual pieces, splitting the top into individual terms, putting them over the denominator, and then reducing each one of them. So deal with inside the parentheses, and that would be doing what we did in this section, split the terms, and then divide or reduce, however you want to think about it there. And then what would you do next? Because then you'd end up with a simplified term plus another simplified term, those in parentheses, minus, and over here in parentheses, a simplified term minus another simplified term. What are we going to do with that minus? Then you would subtract the second fraction from the first. The second, actually it won't be a fraction anymore, it'll be a second set of terms from the first set. In other words, you will distribute that negative. And then of course you will combine like terms. So again, this is just how I would start these problems. Go ahead and look at the 9x cubed over 3x and the 6x squared over 3x. Simplify those. Then you'll get two separate terms there. You've got the 12x squared y squared over 2xy squared. Then you've got the minus 4xy squared over 2xy squared. Simplify those. And then you've got a term and a term minus two other terms. So that minus is going to get distributed across those two terms. And you can combine like terms. Again, I'm not working these ones out for you. I want to see how you can get there. So it'd be a great thing to start, come to class, see how you did. We can check that. Okay. In fact, maybe I'll take a moment here and get these questions written down for you, what the answer would be on this first one. Let me double check you can still see it. Yeah, up here on this first one, I'll write in the answer. To this one, you should get 6x squared plus 8x minus 5. Down here on this one we just looked at, number 82, I'll have to do a little bit in my head here, pardon me, as I kind of work it through. I want you to try these first, see how you do. on this number 82, in the end, you should end up with 3x squared minus 4x plus 2. Okay, and again, bring your questions to class as needed. And finally, let's look at what if they start to throw in more of a description. So now we're really combining a lot of our skills here. This is number 84 from page 383. Don't panic, you can do this. Divide the sum of y plus 5 squared, quantity squared, and quantity y plus 5 times y minus 5 by 2y. Okay, well, let's treat it as a story problem. Let's take a deep breath. Read it again. Divide the sum of y plus 5 squared and y plus 5, y minus 5 by 2y. So we're dividing, well actually let's, think about how you would start, okay? Tell someone how you'd start. I'll give you a minute to kind of think through what you would do as you're starting to translate this. And then in a moment, I'll talk you through what I would do and show you how I would set this up. Okay, so you've had a chance here to maybe tell somebody what you've got or how you would start here. Divide the sum of. So one of the things that I notice here is I'm dividing a sum. Well, I can't really do any of the dividing until I know what the sum is, and the sum means adding. So in my mind, what we're doing is we're going to be adding first. Okay, the division bar is like the grouping symbol here. So the division bar is another grouping tool. So it means you need to take care of what's happening on either side of it first. Kind of like parentheses tell you to do what's inside them first. And then once I have the sum, then I can write it as a division problem. Once I have it written as a division, like a big fraction, then finally I can split it. Remember, we're in the section that we had to take a polynomial, divide it by a monomial, and split it. So you can imagine, and you can expect that the setup would match that situation. Then split it into terms, into individual fractions, and then divide or reduce like we've been doing. So in this case, when I need to divide a sum by something else, let's look at what that is. Here's my divide. Here's my sum of something and something. Those are the two words that tell me what I'm adding together. Sum of something and something. And here's my other by. I'm dividing the sum by this. So this actually becomes my denominator. This is what I'm dividing by. So as I set this up, 2y is going to be on the bottom. And then as I'm doing my sum, it's going to be this y plus 5 quantity squared plus, this is my sum, my adding of these two things, this and this. So I have y plus 5 times y minus 5. So now I have this written out here and translated, and now I need to simplify. And again, I'm doing the adding first. Is there a way to add this? Well, yes. And again, if your gut instinct is to go ahead and distribute this to FOIL this, that is a great use of our Chapter 6 knowledge here. So we've got a y plus 5 quantity squared. That is going to work out. When you FOIL that, you're going to get y squared plus, it's not y squared plus 25. Remember that that's literally y plus 5 times itself. By definition, times itself. FOIL means you get the y squared plus the 5y on the outside, the 5y on the inside. That's 10y like terms. And then the last times last, 5 times 5 is 25. Over here, we've got first times first is y squared, outside, minus 5y, inside, plus 5y, Last times last is a minus 25. You might recognize this when you have the same pieces, but one's plus, one's minus. Those oi pieces, that outside, inside, cancels each other, okay? And on the bottom, you still have the 2y. So what that works out to when you do all this combining of like terms, you're going to end up with, and this is going to get kind of small here because I didn't leave myself quite enough room, I'm sorry. I have y squared plus another y squared, so that's 2y squared. 10y minus 5y plus 5y, these y's canceled, so I just get a plus 10y. 25 minus 25, those cancel each other out, so I'm just left with the 2y. And then we do our split like we've been doing this entire section. And you get 2y squared over 2y plus 10y over 2y. And then you divide each one of those using the rules. 2y squared over 2y is just going to give you y. 10y over 2y is going to give you 5. So this works out to be just y plus 5. And I'm going to circle this because it's a little hidden here. I should have left myself some more room. And because we're not doing 6.6, don't attempt the preview exercises. Just the review in this section. Don't do the preview exercises. You'll note that on your problem set list.